Welcome everyone to episode 3 of this networking series that we are doing on this channel. If you have not watched episode 1 or 2, I do recommend that you go back through and peek at those. There is a playlist in the description. That way we're all up to date with the same information, going in with the same information and definitions. Today, we're going to be starting off with the data link layer. Again, on the OSI model, that is layer 2. The 5-layer model, that is layer 2. In the TCP/IP model, it does combine physical connections and data links together. For the sake of a little bit of simplicity here, we are going to be breaking those off as there are 2 separate functions. So let's dive into data links. Data links are, we have our physical connection in place, so now it's important that we actually get communication established over that physical link. Data link is all about MAC addresses and negotiation. All about negotiating a link and actually having hardware assigned at each side of that actual link. Let's go in a little bit more detail. What is a MAC address? Well, it stands for Media Access Control. It's a unique network interface controller, NIC identifier. It's a physical address. It's hardware assigned. It's actually part of the network interface card or controller. There is some software that can override the MAC address that you're displaying, as most phones have an option for like a private MAC address or a randomized MAC address. But at the end of the day, that network card, whether it be wireless, whether it be wired, still has a hardware assigned MAC address to that card. MAC addresses are an 8-bit hexadecimal. Means there's 6 hexadecimal new numbers in there. The first couple oftentimes are assigned to a specific manufacturer, such as Intel or Broadcom. Oftentimes you can do a little search. It's called an OUI lookup. You can throw a MAC address in, or the first couple characters of a MAC address in, and it will let you know who the manufacturer of that is. It is a hardware assigned identifier, clear down to the manufacturer that creates that hardware. In practicality, it's a unique hardware identifier for a network device. Again, a network device could be any computer, server, router, printer, anything like that. Any real device connected to the network that has access in that network is going to have a MAC address. Well, let's talk about what is the data link? Why is it so important? Well, the data link layer involves the actual connection of one or more network interface to another. Most importantly, it's the recognition of 2 or more devices being connected. It's no good in them being connected if they don't actually realize they're connected or can't even talk across the physical link that actually exists. The biggest part in that is the negotiation of the link. A few different items here that we're going to go over. A lot of these have been improved over time and have been more automatic functions. But formerly, there used to be crossover cables that were super common. And what they would do is reverse. This is more common in copper cables, such as category cable, even coaxial. What it does is it reverses the transmit pairs and the receive pairs. That means that you don't have to think about it. You transmit on a pair, you receive on a pair, and life is good. More frequently now, there's a feature called Auto MDIX. It's present on most new network interface cards, actually most for the past 10 years. And most switches, everything like that, has Auto MDIX involved. It automatically negotiates the transmit and the receive pairs. So you can just use a straight through cable. It's terminated the same on both sides. and it will negotiate which pairs need to send and which pairs need to receive. Another item that needs negotiation is MTU, which stands for Maximum Transmit Unit. It's the largest byte size of data allowed over this link. Commonly, it's 1,500 bytes, but they can go up to 9,000 bytes with something called jumbo frames. Another item is auto negotiation. This can also be manually set. It's the actual maximum supported link speed by either the cabling, the physical cabling, or by the network card on either side. If they're set to different speeds, if something's set to negotiate at 1 gigabit and one's set to negotiate at like a 10 meg by 10 meg, you're going to have issues and you're going to have data loss because what the device that's transmitting on that gig throughput assumes that that device at the other end can read at a gig throughput. So it's going to be sending data a little bit faster, and that end device that's at that slower speed is not going to actually be able to pick up all the data. You're going to have data loss in that scenario. So it's important that either auto negotiation is set up for the link speed or that they're manually configured to match. That way, that data actually goes through and flows as expected over that link. Finally, in this episode here, we're going to take a peek at the Ethernet frame. This is the actual data that flows through at this layer. It's a little snapshot of what that data looks like. The first item that we have is the destination MAC address. We're going to go a little bit more into depth about each of these items here a little bit later. Next item is the source MAC address. Third item that might be in this layer frame, this is an optional item, is a VLAN tag or a virtual local area network identifier. Talk about VLANs a little bit more as we go over these items. Another one is ether type. It defines the type of data that's actually in the payload, whether it be IP traffic, ICMP traffic. Determines the actual, it identifies the data that is built into the payload. The payload is a dynamic size. It has to have a minimum of 46 bytes. Typically, it has a maximum of 1,500 bytes, but if jumbo frames are enabled, it can go up to 9,000 bytes. We have a pad. That pad comes in if that payload is less than 46 bytes to kind of just add some blank space to fill up that size so that that payload reaches the 46 bytes required. Finally, we have CRC, which stands for Cylindrical Redundancy Check. It's a little checksum value. Let's take a peek at each of these items a little bit more in depth. The first couple are explainable. We have the MAC address of the receiving device, obviously. Important to know where the data in this frame needs to go. Source MAC address is the MAC address of the sending device. We need to know how to get data back to us once we've sent this. VLANs we're going to go just a little bit briefly into. A VLAN or a virtual LAN is a logical segregation of a network where you can have one cable, but you can have data that is somewhat separate from other data running over that same cable with something called a VLAN tag or virtual LAN identifier. Basically, on either side of that cable, as long as everything's, configured right on the equipment, you maybe have a network that's set up for guest users, guest access in a business. Maybe we're moving to VoIP phones, a lot of businesses, so maybe there's a separate network or VLAN that has, that phone or a voice network over it. And this VLAN tag is going to tell that traffic where to go. Maybe a voice VLAN has quality of service. Maybe a guest network has some speed reduction so that you don't have a guest user come in and take up all of your network bandwidth. And this creates a logical separation between them so that data is somewhat protected and segmented off. You don't have your guest users on your main admin network, which may have access to servers or other internal data. VLANs take place at layer 2. That's why that tag is so important in the Ethernet frame. Next item is, again, the type of data in the payload. It just is, hey, is this internet protocol traffic? Hey, is this whatever, internet control messaging protocol? What type of actual data is in here? Next item is the payload, which is the actual layer 3 packet data, which we'll discuss once we get to layer 3. Again, pad's just a little spacer, just a little bit of empty space needed if that payload is a little bit small in size. CRC, silic redundancy check. It is a frame checksum, verifies the integrity of the frame, make sure it's not corrupt or anything during transit. The core components to a frame, the core components to link negotiation, and that brings us to the end of the data link layer. Tune in next episode, and we'll be going through addressing and routing for the network.